Hello, and welcome to the Peterson University notes on section 8.8 of our textbook, Systems of Linear Equations. So we're going to learn how to solve a system by graphing today. I've thrown in a couple of warm-up questions to start with to review what we've seen over the past few days. First question asks us to write the equation of the line through the points 0, 3, and 4, 2. A reminder that we are working in slope-intercept form. We've also called that y equals mx plus b, where m is your slope and b is the y-intercept. Well, we already have the y-intercept given in our 2 points here. 0, 3 is our y-intercept. Remember, the y-intercept means the point where my line is going to cross through the y-axis. So if I know that the b value, or y-intercept, is 3, we just need to calculate the slope. Well, I can use my slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I'll treat the second point listed, 4, 2, as my second point. So in the numerator, and taking the difference of the y's, I'll take 2 minus 3 divided by the difference in the x's, 4 minus 0, which would give us a negative 1/4. Now I just need to fill that into my equation of the line. The slope m will be negative 1/4 times an input of x plus 3. So my equation of the line going through the points 0, 3, and 4, 2 is y equals negative 1/4 x plus 3. Question 2 asks us to graph the line y equals negative 1/2 x plus 3. Remember, if I'm already in slope-intercept form, this is actually pretty quick to graph. I know my y-intercept will be the point 0, 3. Remember, if I were to plug in 0 for x, or in other words, 0 is my input of x, my output would be 3, giving us the y-intercept of 0, 3. Put that on my graph. I see my slope, negative 1/2, and I can count from the point 0, 3 a slope of negative 1/2, or down 1 and right 2. I can count again, down 1 and right 2, and connect. I'm hoping if you're working on paper, you have a ruler and a pencil that's sharpened. You can see mine aren't quite perfect using the stylus on the iPad. In question 3, we're asked to write the equation 2x minus y equals 3 in slope-intercept form, which means I need to solve this equation for y. I'm going to start by subtracting 2x from both sides, which would give me negative y equals negative 2x plus 3. Last step would be to divide both sides by negative 1, because I really just want y, I don't want negative y, and that's just going to change the signs around on both sides here. So positive y, or y, will equal, negative 2x divided by negative 1 will become a positive 2x, and 3 divided by negative 1 will give us a minus 3. And that's all we're asked to do in this question, is change forms. I could take it a step further if I wanted to create an input-output table from this or graph this, but for right now we're just practicing changing forms. Moving forward, little iPhone question about iPhone service providers. When you start shopping for your own phone eventually, you'll be comparing different plans, AT&T, Verizon, T-Mobile. In this question, we're told service providers offer different plans with use of the iPhone. With AT&T, you must purchase the iPhone and pay a monthly fee. With Sprint, you do not have to buy the phone, but pay a higher monthly fee. When is AT&T a better deal than Sprint? Something to think about. We're going to see how to solve a system of equations and decide what that means. Sometimes with a phone carrier, in this case, in Sprint's case, you don't have to buy the phone but pay a higher monthly fee. The place will advertise to you that you don't need to purchase the phone right off the bat. They'll just charge you more each month until the phone is paid off. So at some point, one of those plans will become more expensive than the other. So we need to look at our phone and shopping habits to see, for you, which one would be the better deal. Let's think about some new vocabulary here. I mentioned the iPhone question because we're talking about two plans, an AT&T plan and a Sprint plan. This will lead us into a discussion about systems. A system of linear equations consists of two or more linear equations with the same variables. Two or more linear equations with the same variables. And we'll take a look at what that means here in a moment. A solution of your system would be an ordered pair that's true in both equations. An ordered pair, true, I'm trying to fit everything in on the iPad here. An ordered pair true in both equations. Well, what does that mean? Well, I had the warm-up on here to practice graphing one line. We're going to look at graphing more than one line in the next slide. In this slide, we're asked to solve the system of linear equations. We saw earlier in the troll question to solve a system means to come up with the ordered pair that makes both equations true at the same time. Or in other words, where do these intersect? Now, luckily, both equations are given in slope-intercept form, so this might be very quick to graph. Our first step in graphing would be to graph the two lines. To graph the lines. To help me just differentiate between these two and make it clear, I'm going to write equation 1, equation 1's graph in black. I see that I have a y-intercept of 1, so I'm going to place my point at 0, 1 and count my slope of -1, which would be down 1 and right 1. And fill in my line. I'm going to have to do this really carefully with the stylus on the iPad to make it very clear. I'm going to go ahead and put equation 2 in red just to show up the difference here. It's not required for you to use different colors when you do this. I like to use 2 so that I can very quickly look and see the difference between both equations and see which one is my first one, which one is my second one. Equation 2 has a y-intercept of -2. I'm going to put a point at -2. And my slope is 2, so I'll count up 2 and right 1. And I can continue to count another up 2, right 1 to get more points along the line if I need to. If I'm working on paper, clearly I'm going to use a ruler. This is a place where it's very, very important to use a ruler because we are looking on the graph for a point of intersection. And I can see that right here, that occurs at the point 1, 0. Which is also step 2 of what I want to do. Identify the point of intersection. Identify point of intersection. And step 3, I want to check my work. I can check my work by plugging in this point into both equations. In other words, in equation 1, let's see, 1 is my x-coordinate and 0 is my y-coordinate. I'm going to plug this in to equation 1, 0 for y, and I want to make sure, does that in fact equal negative x or -1 plus 1? It sure does. So 1, 0 is true in equation 1. I'm going to do the same to plug in equation 2. 0 goes in for y, and I have 2 times x, or in other words 2 times 1, because my x value is 1 minus 2. I see that I'm saying that 0 equals 2 minus 2, which is also true. So yes, 1, 0 is the solution to this system of equations at the point of intersection. Because it's the point of an intersection and it's the point that is the only one that's shared by both lines, when I plug this into the equation, it will make both of these true at the exact same time. This system, I'm looking below, has one point of intersection. It has one solution. A solution, remember, is where my 2 or more lines intersect. Is it possible, or do you think it is possible, for a linear system to have no solution? If so, what would the graph look like? So take a moment and think about that. Is it possible to have a graph with no solution In other words, meaning you don't have any lines that intersect each other. So take a moment to think about that. If the thought occurred to you that, well, they must be parallel because they would never intersect, you're correct. Give yourself a pat on the back. I can see this in my example given in example 2. Y equals negative 3x plus 1 and y equals negative 3x plus 4. Now, if you're doing some good detective work and you notice that both of these have this same slope of negative 3, you're done. You can look at that and know that those are parallel without graphing. And I'm going to say right here that this has no solution. I know these lines are parallel, therefore they'll never intersect. Now, if you are doubting me, you're not sure, or maybe we don't notice right away that these lines are parallel, I can graph them and see that. So I'm going to graph equation 1 in the black marker again. I have a y-intercept of 1 with a slope of negative 3. So I'm going to put my y-intercept of 1 on the graph, and I'm going to count my slope down 3, right 1, and do my best without the ruler, with my stylus on the iPad. I'm also going to put equation 2, graph this line in red. I have a y-intercept of 4 with a slope of negative 3. So once again, I'm going to count down 1, 2, 3, and write 1. And as carefully as I can on the iPad, graph these lines. You can test me on graph paper with a ruler and see that these are in fact parallel. They'll never intersect. Therefore, I have no solution. Oops. Let's look at another situation here. We saw on the previous slide, I had a system with no solution. Is it possible to have a system, and by system I mean 2 or more equations in the same plane using the same variables? Is it possible to have a system with more than one solution, with many solutions? Think to yourself, where might that occur? How could that be possible? If you thought to yourself, well, that would have to be the same line twice, sharing all points. You are correct. Let's see what that looks like. I have a system, x minus 2y equals 4 and 2x minus 4y equals 8. It's up to you to graph. Do you want to change this to slope-intercept form? Might be easier. Or as you notice, these are both in standard form. You could use the intercepts if you want to. When I look at this, I do think equation 1 would actually be easier to use my intercepts rather than changing to slope-intercept form. So I'm going to do that. I'm going to show my work over here under where it says equation 1. So I have x minus 2y equals 4. Let's see, when x is 0, y would have to be, let's see, this would go away, negative 2y equals 4. Y would have to be negative 2. So I have a y-intercept of 0, negative 2. I'll put that point on the graph. Similarly, to get the x-intercept, when I plug in 0 for y, my negative 2y would go away. I'd be left with x equals 4. So my x-intercept would have to be 4, 0. And I'll put that on the graph. And carefully create my line. In equation 2, I'll do that one in red again. I have 2x minus 4y equals 8. It's up to you if you want to use intercepts. Go for it. If you want to change the slope-intercept form, I'll change this one to demonstrate how I would do that. I'm going to subtract 2x from both sides. Remember, my goal is to get the y alone. I'm left with negative 4y equals negative 2x plus 8. And then I can divide both sides by negative 4. And I'm left with y equals 1/2 x, because my negative 2 over negative 4 will reduce to 1/2 x minus 2. When I graph this on the same plane, I notice again I'm starting at a y-intercept of negative 2, and I'm counting up 1 over 2, up 1 over 2. And I see that in fact both of these lines share all the same points. It's the same line overlapping with itself. In this case, we say we have all solutions. Every solution is exactly the same forever and ever on both of these lines. Any coordinate that I plug in to either equation will work for both. Pretty cool. Now that we've seen what these different systems look like, let's go back now to that iPhone question. How can we apply this new information that we've learned? Now I'm going to give you numbers for these plans. Instead of just saying, oh, one costs more than the other, let's actually look at some numbers and payment plans here. So I'm saying with AT&T, you'd pay $300 for the iPhone, and then you'd pay $40 a month for service, meaning you're texting, calling, web browsing, just $40 flat fee per month. And then Sprint, use green for that, the phone is free, and you can't see my air quotes around free. The phone is free, and you pay $60 per month. I don't know if it's really free. You can see you're paying more per month to cover that cost of the phone. My point earlier was that eventually you will have paid off the phone. So if you're paying $60 a month forever, how much more eventually you're going to end up paying than AT&T? Or is AT&T going to be more? And we can use algebra to figure this out. So let's think about how to model both of these using a linear equation. Because we eventually want to be able to answer the questions, A, after how many months are the total costs of the plans the same? And also in B, when is AT&T the better deal than Sprint? So if we think about X in both of these, remember in a system, the variables stand for the same thing in both equations. In this case, my input, X, if I'm paying $40 per month and my time is affecting the payment, seems to me our X would be time in months. So I'm going to say number of months. And Y, as we go on through time, we're talking about the cost of the phone. So Y would have to be my cost. I'm going to model my AT&T. My cost, Y, would have to equal $40 times X months plus the $300 I've just paid. That's a one-time fee, so that's why it's a constant by itself, $300. With Sprint, I don't have a one-time fee. All I'm saying is that my cost, Y, is going to equal $60 times X months of service. So let's think about this. I'm going to bring up a blank page. So let's see. AT&T, we said, was 40x plus 300. And Sprint, the cost was 60x. And let's just think about what's going on here. If we think about month 1, for example. Here's my AT&T, here's my Sprint. If I plug in $40 times 1 month would be $40 plus the $300 I've paid for the phone. In 1 month, I've paid $340 for AT&T, but notice in 1 month, 60 times 1, I'd only pay $60 for Sprint. So if for some reason I'm going to keep my phone for 1 month and that's it, Sprint is certainly much less expensive. If I go into month 2, well, AT&T have already paid that $300 fee one time, so you can almost think of it, I'm just adding $40 each month. I would also see that if I plug 2 in for X, 40 times 2 is 80, plus 300 would give me 380. Sprint, 60 times 2, after 2 months I will have paid 120. So I can see again, if for some reason I only kept my phone for 2 months, Sprint would still be cheaper. So the idea is I'm continuing this on to see when are they going to cost the same. Now I could continue to number 3, 4, so on, but now we have this power of systems of equations that we know how to solve. So wouldn't it make sense to be able to graph both of these? And in fact, I actually don't even need the whole Cartesian plane. All we need is the first quadrant because we're only talking about positive numbers. So I can make a really big first quadrant. My x-axis would be time in months, and my y-axis would be the cost. I'm going to challenge you to graph this, either attempt to graph it by hand, or I'll give you a hint that this one, maybe the numbers aren't friendly, to try to graph it in Desmos. You'll have to zoom in quite close to see when are these going to cost the same. When do Sprint and AT&T eventually crisscross over in their graphs, and what is the point of intersection? At what point do these flip-flop and Sprint becomes more expensive than AT&T? I'm going to leave you with that question to challenge you. I'd love for you to go ahead and give that a try.